In this video, we are going to explain the previous year question papers of maths, and this is the first question from 2015. Now look at here, the given question is prove that the 3 plus 2 root 5 is an irrational number. So let us assume the given number is a rational number. Assume 3 plus 2 root 5 is a rational number. And then take 3 plus 2 root 5 is equal to a by b, where a comma b are coprimes. Then squaring on both sides, do the squaring on both sides. 3 plus 2 root 5 whole square is equal to a by b whole square. Then take it as a plus b whole square. Take it as this is a and this is b. A plus b whole square right here. A plus b whole square is equal to a square plus b square plus 2ab. Here a is nothing but 3. So 3 square plus b is nothing but 2 root 5. 2 root 5 whole square plus 2 into a is 3 into 2 root 5. 2 root 5 is equal to a square by b square. So here 3 square is 9 plus 2 square is 4 into root 5 square is 5 plus 2 into 3 is 6 into 2 root 5 is equal to a square by b square. 9 plus 4 5 is 20 plus 6 2 is 12 root 5 is equal to a square by b square. So here 9 plus 20 is 29 plus 12 root 5 is equal to a square by b square. Then write this numerical value 29 that side and take that side and remaining 12 also. Then what you will get? Root 5 is equal to, all right, in the next step, 12 root 5 is equal to a square by b square minus 29. Then 12 is equal to, not 12, root 5 is equal to a square minus b square into 29 by 12 b square. This is the final answer. So here we can observe that root 5, we have assumed that root 3 plus 2 root 5 is an irrational number, and here we got root 5 is a rational number. Here it is in the form of root 5 is in the form of fraction. So here it is in the form of a square minus b square 29 by 2 into b square. So it is in the form of root 5 is a rational number here. But we know that universal truth is root 5 is an irrational number. Our assumption is wrong because root 5 is an irrational number. So 3 plus 2 root 5 is also a irrational number. Next question. This question is from 2015 March. 8 marks question. At that time, 4 marks for this academic year, 8 marks. Now again, the one more question. Prove that root 2 minus 3 root 5 is an irrational number. Here, root 2 minus 3 root 5 is equal to a by b. We should take. We know that we have to assume that root 2 minus 3 root 5 is a rational number. A rational number. And where a comma b are co-primes. Then sparing on both sides. Sparing on both sides. Root 2 minus 3 root 5 whole square is equal to a by b whole square. So again, it is in the form of a minus b whole square, a by b whole square. A minus b whole square is equal to a square plus b square minus 2ab. A square is nothing but root 2 whole square plus b square is 3 root 5 whole square minus 2 a is nothing but root 2 into b is 3 root 5 is equal to a square by b square. So here square root is gets cancelled. So the value is 2 plus 3 square is 9 and root 5 is 5. Square root gets cancelled. Minus 2 into root 2 is 2 root 2 into 3 root 5 is equal to a square by b square. So here 2 plus 9 5 is a 45 minus 2 into 3 is 6. Root 2 into root 5 is root 10 is equal to a square by b square. Since here we can write root a into root b is equal to root ab. Here 2 plus 45 is 47. minus 6 root 10 equal to a square by b square, and then minus 6 root 10 is equal to a square by b square minus 47 minus 6 root 10 is equal to a square minus b square 47 or 47 b square by b square, and send that 10 minus 10 6 that side. Root 10 is equal to a square minus 47 b square by minus 6 b square. Now again it is in the form of a by b, so it is in the form of fraction, it is a rational. So here root 10 is a rational number, but our assumption is wrong. Assumption is wrong. Root 10 is a irrational number. Hence root 3 minus 2 root 5 is also a root 2 minus 3 root 5. Root 2 minus 3 root 5 is also a irrational number. So this question is from 2016 March. 2016 March. In that year, 4 marks. Maybe for this academic year, maybe 8 marks. One more question. Use Euclid's division lemma to show that the cube of any positive integer is of the form. So here clearly mentioned cube of any positive integer. So here given form is 7m plus 1 and 7m plus 6. So number of terms here 3 are there. First term, second term, third term. So here we should take r is equal to 3. So take r is equal to 0, 1, 2. So up to 3 digits. And Euclid's lemma division formula is A is equal to BQ plus R. So here BQ plus R form. Then B value is equal to 7. And clearly mentioned here cube of any positive integer. A is a positive integer. A is any positive integer. Then take A is equal to BQ plus R and substitute the values of B and R in this. If R is equal to 0, B is equal to 7, A is equal to 7Q plus 0, that equal to A is equal to 7Q. Clearly mentioned in the question, cube of any positive integer. So cubing on both sides, cubing on both sides. That equal to a cube is equal to 1 cube whole cube. So here a cube is equal to 7 cube is 31343 into q cube. 343 can be written as 7 into 49 into q cube. Now consider, let us assume let us assume 49 q cube is equal to m. Then a cube is equal to 7 into 49 q cube is m, 7m. Then take if r is equal to 1 and b is equal to 7. A is equal to 7m, 7q plus r is 1. Then cubing on both sides. Cubing on both sides. A cube is equal to 7q plus 1 whole cube. A cube is equal to a plus b whole cube. So here it is in the form of a plus b whole cube. A cube plus b cube plus 3ab of a plus b. Right here, a cube is nothing but 7q whole cube plus b cube is 1 cube plus 3 into a is 7q into b is 1 of a plus b. 7q plus 1. Here we can write as 343 q cube plus 1 plus 3 7 21 q into 1 is 21 only. 7q plus 1. Now take 7 common from this and these two terms. Then 7 of, here again remaining is 49 q cube plus from this term if you take 7, 3q of 7q plus 1 and remaining plus 1. Now let us assume let us assume 49q q plus 3q into 7q 3q into 7q plus 1 is equal to m. Okay, then what you will get? 7 into this whole term is m plus this is 1. So total value is a cube is equal to 7m plus 1. Now consider one more. If r is equal to 0 over, r is equal to 1 over, and take r is equal to 2. Now if r is equal to 2 and b is equal to 7, a is equal to 7q plus 2 cubing on both sides. So a is equal to a cube is equal to 7 cube plus 2 whole cube. A cube is equal to, so it is in the form of a plus b whole cube. So a plus b whole cube, a cube plus b cube plus 3ab of a plus b. So here the cube is 7 cube whole cube plus b cube is 2 cube plus 3 into 7 cube into 2 of a plus b. A is 7 cube plus b is 2. That equal to 343 q cube plus 2 cube is 8. So what is asked in the question? 7m plus 6 in the form he asked. So plus 3 7 21 cube into 2. So 40. We can do one thing here. So 3 2 is a 6 into 7 cube. 7 cube plus 2. Here split this 8 as into 6 plus 2. And here we can take 7 common. 7 of 49 q cube. Here plus, here we can take 7 common. 7 of 6q into 7q plus 2. Then split it as plus 6 plus 2. Now take 7 common from this term and this term. This and this term. So write it as 7 of 49 q cube plus 6q into 7q plus 2 and add this 2 also here plus 6. Now let us assume this whole term from here to here, take it as m 49 q cube plus 6q into 7q plus 2 plus 2 is equal to m. Then 7m plus 6. So a cube is equal to 7m plus 6. If you observe the cube of any positive integer, this integer here, a is a positive integer or a whole number. Okay, here a is equal to, so a whole number, any whole number is in the form of clearly given in the question. Cube of any positive integer is given, not a whole number. Any positive integer is of the form any positive number or integer is of the form a cube a 7m or 7m plus 1 or 7m plus 6, hence proved. So remaining questions we will discuss in the next session.